Section 3.4, Section 3.4, addition and subtraction. I think the attendance is low today because people looked at the topic and said, oh, my God, I don't want to addition, subtraction of radical expressions. Oh my God. Does that sound horrible? I think I would have taken off if I was in class now, back in the 1960s and 70s. Okay, well, what does this mean? This is actually important because this has to do with like terms and unlike terms. Similar, like you know that 7x plus 4x are called like terms, right? Like you cannot add 7x plus 4y. These are called unlike terms. To use, a basic algebra example to begin the class, these are like terms, these are unlike terms. So when we're talking about radicals, what are like terms and what are unlike terms? In other words, when can we add radicals or subtract them, and when can we not? Well, in this case, you can add these two radicals. And what makes them like radicals or like term, I don't want to call them like terms because there must be another name for them, but I didn't look in the textbook. But these are considered like terms. So the answer here would simply be 11 times the square root of x, not 11 times the square root of x squared. That's not how you add them. See, just like over here, I've had students in my past, not this level, of course, who've done this. I've seen that. No good. You keep the term, you keep the variable and add the coefficients. You keep the radical and add the coefficients, so to speak. I don't even know if you call these coefficients, but that's how you do it. These are considered like terms. These are not considered terms that you could add. Yes, they do have the same radical, but this is different. There's an x here and there's nothing over there, so you can't add these two and get 11x, for example. You can't do this. That's not allowed. They have to, in other words, this can be added to this, and we would wind up with 11x times the square root of x. So you could do this. These are considered terms that you can combine. These are considered terms that you can combine. This cannot be combined. This cannot be combined either. This is no good either. Well, that's pretty obvious, right? But if you put in there a y, then you could combine them and you would get this. See, these are all the basic building blocks of the concept of combining, and that by combining, I mean adding or subtracting radical expressions. And let's take an example of something that you might be faced with. I'm going to let you look at it, and I'm also going to let you sort of play with it and see what you can come up with. Well, the way you do this problem is by leaving this alone because this is pretty much simplified the best way you can. Put the minus sign over there. Separate this into two parts. That's how I would do it. Continue. This is equal to x squared times the square root of 11. So what I did was I took the square root of x to the fourth, which is x squared, and then, switched it around so that that was in front and that was behind. And this is good, because not only do we have the same radicals, but we also have the same variables there. And the answer here is 6x squared times the square root of 11. And that's the answer to the question. Somebody's dying to reach me. This is like the 8th time they've called me. Let me see what's going on here. I'm in the middle of teaching a class. I'm a college professor, so this better be pretty important. Hello? That got rid of them pretty fast. I think I frightened somebody to death. Okay, are there any questions about that? A little weird, right? Yes.
No. I said no.
Sundays? No?
No.
You get it?
Yeah.
Okay, next question. Question 3. Okay, so this is I like this question very, very much. But here's something more difficult, because we are, after all, a pre-calculus class. So here it is. Here's the biggie. And I'd like you to do this if you can. 80 a b to the third minus 5b times the square root of 45 a to the fifth b. So my direction to you now is play with that and see how you do. And I'm going to begin going over it. Well, it's quite challenging. I'm not going to sugarcoat it. So this is what you do. It's one of these problems. Where you're going to take the perfect square factor of 80ab to the third and keep it in here, and then whatever else, you're going to do that. So the highest perfect square factor of 80 is 16. And then this is 5. Now, there's nothing you can do with that. You need at least an even number out of that. There's nothing you could do, so keep that in there. Here, you could put b to the second, and here you could put b. Okay, so that's how you separate 80ab to the third, the perfect square times the number. A, there's nothing you can do with, so you stick it in the junk pile, so to speak. And b to the third, you make b to the second, and then b. Okay? And let's leave it like that and go here. Now, this is going to be the key one over here. So that would lead you to immediately say, and this is how I'm doing the problem when I'm doing this. I'm saying, well, if it's going to be a 5 over there, it seems to me that there should be a 5 over there. So let's try 5 into 45. Yeah, because here's the perfect square. And here is the a to the fourth and the a. And since there's a 5ab, Guess what that's going to be? Yes, it's going to be a B. Yeah. That's how you would do that. Is there anybody who's, well, let me continue. So 3a squared times the square root of 16 is 4, the square root of b squared is b, times 5ab minus 5b times the square root of 9a to the fourth is 3a squared times the square root of 5ab. And then combining these two, you get 12a squared b times the square root of 5ab minus 15a squared b times the square root of 5ab. So magically, well, not really magically, but for dramatic purposes, dramatically, you have the same radical, that's good, the same variables outside the radical, and now you're able to combine 12, positive 12, yes, and negative 15. And that will give you negative 3. And then bring everything else along. And this is the answer to the question. I guess that's a hard problem. What I basically did was, I didn't say to myself when I was doing this problem, well, I need, this to be that, and I need this to be that. I simply simplified a radical the way we've been doing it in previous sections, right? All I did was say, let me simplify this. And I did it over here, and I wound up with this. And I simplified 45a to the fifth b. I did all that, and then I put them together. And as I was putting them together, I began to realize that these two could be combined. I mean, I knew they were going to be combined, but I didn't think about that when I started to do the problem. When I started to do the problem, all I thought about was, well, you have to simplify this. Well, you have to simplify this. And I kept doing it and kept going. And then as I got to the bottom, I started saying, will we be able to combine these? And I knew we were going to be able to, because this problem I got out of the workbook. So I knew it was going to work out. And there it is. And that's the end of the problem.